that will be the giant companies of the future. You know, the title of this talk was AI as the New Electricity, and I think that about 100 years ago, as we started to build electricity into the United States, that changed industry after industry, right? Everything from manufacturing, agriculture, healthcare, transportation, communications was transformed with electricity. I mean, if not for electricity, this would be a completely dark room, right? So this really transformed the world. And I think AI technology, specifically machine learning, but other things too, is now reached a stage of maturity where we see a surprisingly clear path for it to also transform every industry. So what I want to do today was, as I was preparing this presentation, I spent some time thinking over what might be most useful to you, and I thought I'd do something different and do a whiteboard presentation to chat over how I think some of you might be able to use AI in your startups. I think they're going to project to the big screen, right? So I'm going to draw on this, and is the camera person? Oh, okay, awesome, thank you. So, a lot of basic ideas of AI have been around for many decades. So a question I've often been asked is, people have asked me, hey, Andrew, why is AI finally taking off now? So let me draw a picture. That is the picture I draw when people ask me that question. And if someone asks you the same question, you could draw the same picture for them. If on the x-axis we plot the amount of data you have for a problem, then what's happened in society over the last 20 years is with the rise of the internet, the rise of mobile devices, we've just accumulated more and more and more data for a lot of problems. For example, once upon a time in the supply chain, if you order something, the fact that you ordered a notebook, that would be recorded on a piece of paper. And maybe that piece of paper is somewhere in a filing cabinet in the Philippines. Today, the fact that you place an order for something or you order the TV is much more likely to be a digital record in a computer. So the digitalization of society created data. And now on the vertical axis, I plot performance. Then what happened was, for the earlier generations of AI, for the traditional machine learning algorithms, you want to write traditional ML for traditional machine learning, it was as if for the early generations of algorithms, logistic regression, support vector machines, maybe decision trees, it was as if they didn't know what to do with all the data you can now feed it. But in industry after industry, we've been seeing that when you train a neural network, so if you train a small neural network, NN stands for neural network, then the performance sort of gets better. If you train a medium-sized neural network, and if you train a very large neural network, then the performance sort of keeps going up. And this means a couple of things. One is, well, if you want to get the best possible performance, right, if you want performance all the way up there, you kind of need two things. One is it really helps if you have a lot of data, and maybe big data is one of the buzzwords people sometimes use. And second is you need to computational power to train maybe the big enough neural networks in order to take advantage of that data. Although, thanks to the rise of GPU computing, I think that more and more people, including startups now, have access to, the whatever, 1 to half dozen to maybe a couple dozen GPUs that you need in order to take advantage of the data sets you might be able to acquire. Now, there's a ton of hype about AI, and I want to share with you just what's really working and what's really useful. Despite all the hype, and the fact that it will transform industry after industry, almost all the economic value created through modern AI, and I think also the best opportunities for many of your startups is through one type of AI, which is just learning A to B or input to output mappings, and this is called supervised learning. But as an example, for a long time we've had algorithms that could input an email and tell us if it's spam or not, right? 0 or 1. This is supervised learning, A to B or input to output. I once did some work on loan applications where you input a loan application that's A and map it to an output B that says, will they repay this loan, 0 or 1? And this turns out to be a good way to decide what loans to approve. This is a decent business. The most lucrative application of this on the planet today, I believe, is online advertising, where the large online ad platforms all have an algorithm that inputs an ad and some information about you and outputs will you click on this ad. Because for all of the for the large online advertising platforms, every click is money. And so there's a very large financial incentive to build the best possible system to show you the ad that you have a 5% chance of clicking on rather than a 4% chance of clicking on. Maybe not the most inspiring application of AI, maybe, but certainly incredibly lucrative. Speech recognition. Input an audio clip, output a text transcript. And, you know, some of you will have, I guess, Amazon Echoes or like Google Homes or like Apple Siri like devices in your homes. The main reason you're willing to accept these devices today is when you say, Alexa, you know, whatever, Alexa, what time is it? The chance of the Amazon Echo waking up is very high. If it responded to you only 50% of the time, you won't use it. The consumer experience is just unacceptable. But we're willing to use speech recognition devices like Amazon Echo or Google Voice Search or Baidu Voice Search because speech recognition accuracy is really high. So we actually still live in an era where, for a lot of applications, having great AI technology matters. Because if your speech recognition system's accuracy is 99%, the users might love it. If your speech recognition accuracy was 95%, users might not be willing to accept your product. And so we still live in an era where having great AI teams to really get the best performance out of the technology matters to the user acceptance. And online advertising as well, right? Every click is revenue, so the ability to show a slightly better ad is incredibly lucrative. And maybe this is why we live in an era where the quality of the AI technology really matters. A lot of other examples. Input an electronic health record and output. This is one of my students, Anand Avanti at Stanford, did this, right? Input your health record, estimate the chance of someone, you know, mortality in the next year. This helps steer people to palliative care. Self-driving cars. One of the key components is input a picture and maybe the radar or LiDAR readings and output the position of other cars. Right? So at self-driving companies, I guess I'm on the board of Drive.ai, and really lots of self-driving car companies. This is a key component where, again, the quality of the technology matters. Mentioned I'm working at Landing AI, which is helping manufacturers transform using AI. So one of the things we do is input the image of a part. You know, picture of a consumer electronics device that you may have in your home or that you may carry with you, and output, you know, is there a defect, right? And again, it turns out the machine learning algorithms needed to do this is really tricky, but when you can do this, you can carry out inspection tasks automatically, and this is very valuable. So this is just learning A to B mappings, right? This is supervised learning. But when you find the right business use case, when you find the right business context, this turns out to be incredibly valuable. Now, I like to cut through hype of machine learning and AI because there's a lot of hype. Turns out that you read in the media about a lot of different types of AI technology. And so you hear about, I'm getting a little bit technical, I guess, supervised learning, that's learning A to B mappings, transfer learning, which is learn from one task, like learn to recognize cats and use what you learn from recognized cats to read X-ray images because there are a lot more pictures of cats around than there are X-ray images. You hear about unsupervised learning, learning without labeled data, and you hear about reinforcement learning, which is great for playing Atari games and playing, you know, various sorts of games. It turns out that the PR you see is not at all proportionate to the short-term opportunities and the economic value created. The value created as you go down this list rapidly decreases. And so I actually think that many of the best opportunities for you will be in supervised learning. Although the AI deep learning work changes so fast, it's entirely possible that there'll be new inventions and this order will flip around in 2 years or 5 years. But at least today, I think the media reporting is not proportionate to the actual value created. Although we like future technology though. So in the future, maybe in 2 years, this ordering will change. One other ordering insight that may be useful is most of the hype is on AI applied to unstructured data, and that means things like images and audio clips and text, because we're very human. We like it when the learning algorithm seems to understand language, right? Because we all, you know, like pictures. But it turns out that if you look at the economic value created, there's actually, let's see, structured data. So structured data means, you know, your database of transactional records, who visited what website, what did they purchase, how many minutes was this phone call. Those are examples of structured data. And once again, it's fun to read news articles about computer vision recognizing cats. That's unstructured data, image data. But at least today, there's actually more economic value created through machine learning applied to structured data, to like your boring database records. Although I think that things on unstructured data, like speech recognition, will create new categories of products, like the smart home speakers. I want to share with you one perspective on AI. And if you remember just one thing from this talk, remember what I want to share with you next. Let's see, I spent a lot of time looking at the rise of the internet, right? Rise of the internet as the previous wave of, as one earlier previous wave of technological disruption. And one of the lessons I learned was if you take your favorite shopping mall, right? My wife likes Stanford Shopping Center, right? But and let's say you build a website for the shopping mall, and shopping mall can sell stuff on the website. This does not turn the shopping mall into an internet company. Right? This is really obvious today, but there were actually retailers maybe 5 years ago that said things like, look, Amazon has a website, we got a website. Amazon sells stuff on the website, we sell stuff on the website. It's the same thing, but of course it's not the same thing. So what's the difference between a shopping mall plus a website versus an internet company? The difference is, have you organized your company to do the things the internet lets you do really well? For example, internet companies were used to pervasive A/B testing, because you can, and if you don't, your competitors will, and they'll learn faster. We're used to short shipping times, right? Traditional shopping mall might ship a product may rearrange things every 6 months. Internet companies, we ship a product every week, or maybe even every day, because we can and we learn much faster that way. We, as internet companies, have learned to push decision-making down to the engineers and the product managers. So you cannot have an internet company where the CEO says everything and everyone just does what the CEO says, because it's impossible for the CEO to know enough, at least when the company grows. So this is why we push a lot of decision-making down to the engineers and the product managers, because only they understand the tech and the users well enough to make great decisions. So this was the internet era. How about the rise of the AI era? I think a traditional tech company plus, a few neural networks or deep learning or machine learning or whatever, this does not make the company an AI company. And I think one of the best opportunities for startups, and why I think there'll be great AI startups built today, is just as with the rise of the internet, some incumbents did a great job transforming themselves. I think Microsoft and Apple did a great job transforming themselves to be internet companies. There were also startups, such as Google, Facebook, and Amazon, and Baidu, and so on, that did a great job rising up with the internet. With the AI era, I am biased since I led teams at Google and Baidu, but I think Google and Baidu have done a great job transforming themselves to be great AI organizations. Not yet done, still more work to be done, right, frankly? No one's done. We're also trying to figure out what's the bulleted list that should come down here. But I think that just like the last wave, some incumbents, Google, Baidu, and a few others, I think Facebook, Microsoft, Amazon are great. I think there'll be new startups as well that figure these things out. Now, we don't totally know what are these things down here, but I'll just mention a few. Strategic data acquisition. One of the, I'll say more about that later, but in a lot of AI businesses, there's actually data, even more than the technology, that creates a defensible barrier for your business. And so, for example, in China, people speak slightly different languages in different regions. So I've done things like launch a product in one location, to acquire data, use that to attack the neighboring location where the language is slightly different, use the data from first two regions to go to the third region, but we don't monetize any of this. We take all this data and we monetize it in a totally different location. So both, like competitors and we've all done things that make no sense from a revenue point of view, and it's because we're playing this multi-year chess game in terms of data acquisition. So I'm seeing the great AI organizations get really sophisticated in terms of thinking through these multi-year data acquisition strategies. This is less of a problem for startups, but more for traditional companies. The large companies are doing a lot of work to unify the data warehouses, because there's only a few, from instead of having like 50 siloed data warehouses, put it together in a single data warehouse that your engineers and your software can even look at it to create value. I find that we're very good at spotting automation opportunities. So for example, one rule of thumb I've given to a lot of my teams is almost anything that a typical human can do in less than a second of mental thought, we could probably now or soon automate, right? So I've actually had product managers running around my teams trying to think, what are things that I could do in less than a second? Because those are often good candidates for automation in the near future using machine learning. And then there's one very complicated category of new job descriptions. You know, I think it was really, I think Microsoft had pioneered the role of the program manager. But in Silicon Valley, we have roles like product manager, program manager, and we've figured out this workflow of how to write, you know, mobile apps or web apps, right? The product manager draws a wireframe, and then the engineer, you know, maybe tries to implement that. And we'll figure out how teams work together. In the AI era, these workflows are breaking down. So for example, right, well, you guys know what a wireframe is, right? So, you know, a product manager draws a picture, maybe you're designing the Facebook app or something. Maybe a product manager draws a picture like this, and then the engineer implements that, right? That's the wireframe. But say you're building a self-driving car. If a product manager comes to you and draws this picture, and shows this picture to the engineer and says, hey, build this. The engineer will say, this is totally useless. Why are you drawing a picture for me? So we figured out that in the AI era, we're training our product managers to the PRD, the new PRD, the new product requirements document is a data set together with an evaluation metric and a request. Like product managers might take a data set to an engineer and say, hey, do you think you can get 99% accuracy detecting all vehicles less than 50 meters from our vehicle? And that is how a product manager specifies. And so this, I think, is the job descriptions in the AI era, and the way we break up tasks is very different. So I think that, you know, 20 years ago, we did not know. I did not know. I don't think any of us knew how important A/B testing would be for the internet era. I think that we're still all of us, even the great AI companies, are still figuring out what are the things on this list on the right. And I think some incumbents will do a great job figuring these out and transforming. But hopefully, I think that there'll also be some startups that will, you know, be the great companies of tomorrow because of this wave of technological disruption. Now, I just want to mention one last piece of advice, which is how do you get into AI, right? I actually get asked that a lot. How do you break into AI? Because there's so many opportunities to use machine learning, but machine learning talent is scarce, and technology is really difficult. I was really surprised in the manufacturing realm. It really forced us to use AI technology that was invented in the last 2 years to do some things we do. So the AI technology is actually really complicated. But if you think about how you learn to code, right? You did not learn to code by jumping into, I don't know, the open source, you know, Mozilla code base or some huge project. You learn to code by Hello World, and then learning to print numbers from 1 to 10, and then eventually implementing Quicksort or whatever. So for people that want to get involved in AI, I think that, you know, online courses, or really digital content, things like courses we teach on Coursera, is actually a very good on-ramp to learn about the foundations. And then beyond that, I've been fortunate to mentor a lot of Stanford PhD students. It's a pretty predictable, repeatable process, but it's often a good idea to try to replicate existing results. And if you do this, read research papers, replicate published results, people tend to underappreciate how important this is. When you show up, you know, with a new project, or if you have an interview somewhere, these things really matter. And then finally, you know, by the way, when all of us interview open source, I mean, when you have stuff on GitHub, right, or with your written blog posts, that really counts. But there's a fairly predictable process for teams to get great at AI. And so, you know, by all means, try to hire the Stanford AI PhD students or the Berkeley AI PhD students or whatever if you can. But we now have great resources to help you learn these ideas to try to incorporate them. So AI is the new electricity. I find it hard to think of an industry that AI will not transform. And for us to implement this societal change, the only way to do so is for really all of you, many of you, to build the great companies of the future that will help make the whole world better using AI. Thank you very much. Thank you. Thank you.